All right, on this notes, I didn't put a review one for the first semester because I knew it was a flex day and it's a shorter day, so we need to get it done a little quicker. So I just wanted to get to the notes. Now, the section 7.2 is about vectors. Now, a vector, we did talk about a vector before. I don't know if you remember it. We did talk about a vector before. Remember anything in the first semester that had to do with vectors? Okay, we had a unit on transformation where we talked about reflection, where something reflects over the x or axis or y axis or whatever, and has symmetry and it's perfect reflection. We also talked about rotating stuff around a point. The third one we talked about was translating something, translation. Do you remember what a translation had in it? Translation was what? What did we do to translate something? We moved it. We just slid it over. We slid it diagonally. We slid it up. And how far you slid it and which direction you slid it was a vector. So that was what we talked about as far as vectors go. And I'm not sure if you, Alex, am I closing on this? I'm not sure if you seen the movie Despicable Me or not. I think we talked about Vector before. He's the little guy and the villain in that movie. And when he goes next to Gru in the little area bank looking for money or whatever, and he was telling Gru that his name is Vector, and he says it's because I have direction and magnitude, right? And exactly what vectors have. They're going to tell you where they're going, and they're going to tell you how far they're going. Okay? Now, a vector is very similar to an array. Now, you look at this, and a vector has an initial point where we start. And a vector goes in one direction, and then it has a terminal point where it ends. Very similar to an array. What's the difference between a vector and an array? Array never stops. Okay, array continues in that direction forever. A vector continues in that direction until it gets to the terminal point, and then it stops. It's not a line segment. Segments have two endpoints that can go either direction, right? A vector can only go one direction. It only starts at its initial point and then goes to its terminal point and then stops. So to get the direction of the vector, we're just going to count over 5 and up 5. That's telling you that direction is positive, positive. You're going to be going up. You're going up positive 5, over positive 5, you're going up positive 5. That's called a direction, telling you which direction to move in to get to that vector, to get to the endpoint. The magnitude comes in where it's how far do you go and how long is this actual vector line right there. Now, if I wanted to find the length of this line right here, what if I want to put a question mark there? If I wanted to find the length of that line, that's called the magnitude. That's the distance. Now, yesterday I kind of showed you the distance formula where you did the x2 minus the x1, and then the y2 minus the y1. So you have that right here, x2 minus x1, y2 minus y1. So you can see that we went over 5 and up 5. If I did x2, which is a 2, right here, minus the x1, negative 3, 2 minus negative 3, that's how I'm going to get my 5. Okay, so that's this side of the triangle. That's my little a if I'm doing Pythagorean theorem. To get this 5 over here, I did the y2, 3, minus the y1, which is negative 2. 3 minus negative 2 also comes out as a 5. So to get my magnitude, I can do 5 squared plus 5 squared equals c squared, and that would be my length. That would be my magnitude of that vector. You could also plug it into that big square root formula that I gave you yesterday too, which is when you have 2 points, you can find the magnitude. So that's just a diagram for you to look at to see. This right here is called component form. You might see it in parentheses. You might see it in like a less than and greater than sign. Okay, they both work. Both work for component form. Component form is the one that gives you the direction and the magnitude, basically. It tells you to go +5, +5. It's telling you to go up, basically. So that's the component form. It's telling you where to travel to get your vector. Initial points they're going to give you, and terminal points they can give you. Component form tells you I'm going over 5 and I'm going up 5. So let's look at the first example. Find the component form of the following vector, and I'm also going to add and magnitude so we can practice. So we want to find the component form and we want to find the magnitude. Okay, so we have vector. Our initial point is A or B. Which one's the initial point? Why? Because it's A? Because where the arrow's pointing. The arrow starts at A and points to B. So that means A has to be initial, B has to be terminal, has to be the end. How do I get from A to B? How do I get from A to B? No, don't say down 2. Down 2 do the second part. We always go across first in vector. So you're going to go over how many? 1, 2, 3, 4, 5, 6, and then down 1, 2. So you're going over 6, you're going down 2. So component form is over, then up or down. So you got to go over first, you got to go up or down second. That's the component form. That tells us the direction that we need to go in. So in this case, for us, the component form would be 6, -2. So that's telling me to go right 6 and to go down 2. That's what that's telling me. That's the direction, right and down. Now the magnitude would be how far to go. So magnitude equals distance. Now to find that, you've got many options. Can you see the right triangle we already made here? So do you see how I could put a box in there and we could do a squared plus b squared equals c squared and we could have our answer right there, right? That would be one way to do it. You could also use the big square root formula and do x2 minus x1, y2 minus y1, get the same answer. Now I think since we already see the triangle, I would just use the Pythagorean theorem then. So magnitude is going to be 6 squared plus -2 squared equals c squared. 36 plus 4, and that's going to be 40. Square root both sides, you're going to get 6.3. So your magnitude, the length of that vector is 6.3. The direction of the vector is to go right and down. Right 6 and down 2 is the direction of the vector. Okay, so if a robot moved from point C, which is 16, -6, to point D, which is 9, -6, then what would represent the displacement vector, which just means vector. When you see displacement vector, it's the same thing, the vector. So what would represent the vector for the robot's movement? Now I did want to put a little note here on the side, just giving you a heads up of some other terminology or another symbol that you might see. There is a little triangle symbol. Triangle, when there's a triangle x, triangle y, that means the change of x, means like x2 minus x1. And it means the change in y, y2 minus y1. How much did x change? How much did y change? If you put a triangle in front of 3 letters, if I was to put triangle ABC, That's talking about a shape that has 3 points, A, B, and C, and that's a triangle. Okay, but when we have triangle X, triangle Y, this means how much did X change? How much did Y change? So, if I'm going to solve this one, we want to find the vector. We want to find how much the change in X was. And we want to find out how much the change in Y was. How much did we go over? How much did we go up or down? Okay, that's what this is. This is how much did we go over? This is how much did we go up or down? So let's see what we did here. Now, to get the change of X, X2 is 9, X1 is 16. 9 minus 16 is negative 7. To get the change of Y, Y2 and Y1, you have negative 6 minus negative 6. That's a double negative, so if you make them pluses, you get 0 there. So what is my vector here? If the robot starts at 16, negative 6, and ends up at 9, negative 6, then what was its actual movement? What was the vector? How far did it go over? How far did it go up and down? It went over how much? Negative 7. That means it went 7 in which direction? Left. Left. Left is negative, right? And then it went how many up or down? 0. It didn't go up or down. So if you picture these 2 points on your graph, over 16 and down 6, over 9 and down 6, you just go left 7 to get to that second point. Because they're both on the negative 6 line. So it would just be a negative 7 and then you wouldn't go anywhere. So negative 7, 0 would be your vector. So the change in X, the change in Y would be those little triangles there. Okay, moving on. Okay, here's another symbol that you're going to want to notice here. You see this little half arrow above the U? That's like a half arrow symbol. That's a vector symbol. So if the vector, and they're calling vector U here, so this right here is the vector symbol. And vector U, this vector right here is telling me to go 3 left and to go 2 up. That's what this vector is telling me to do. Go 3 to the left, go 2 up. So if you don't trust your math and you want to just make this dot right here and go 3 to the left and 2 up and make another dot and then see where it would end up with, then you can get your answer that way. You can draw the picture so you can visually actually see it happening. If you trust yourself and you know that your initial point is 4, 9, and that if we want to apply the vector, and the vector is a negative 3, 2 vector, that our terminal point would be what we get when we combine the vector with the initial point. So what do you get when you combine the 4 with the minus 3? You get a 1. And when you combine a 9 with a 2, you get 11. So that means that if you started at 4, 9, that your initial point was 4, 9, you went 3 to the left and you went 2 up, you would end up at the point 111. If you were not sure about the math and you wanted to visually see it, you could do that. You could start at 4, 9. And you would go 3 to the left. So 1, 2, 3 to the left. And 2 up. So this would be the vector right there. It started at 4, 9. You went 3 to the left, that got you at 1. And you went 2 up, that got you at 11. So 111 is where you would end up at. So So your initial point, you apply your vector to it, you get your terminal point. They gave you the vector. The vector was 3 to the left and 2 up. So the direction was going 3 left and then 2 up. Here it says find the magnitude, which means length. Find out how long this vector is. If it's got an initial point of 0, 0, okay, so graph points. So I would draw a little x and y axis, and A is 0, 0. It's got a terminal point of 5, 4. That's point B. So here's my vector, from there to there. It's going 5 to the right. It's going 4 up. 5 to the right and 4 up. That's your vector. So how's my, what would be my magnitude? How do I find the magnitude of that? This 5, 4, we would call your component form. This tells us to go 5 to the right and go 4 up. So how could I find the length of this vector? How long is that vector from A to B? Pythagorean theorem, right? Your component form is A and B. Here's your A, there's your B. Your component form is your AB, so you're just going to do 5 squared. So magnitude, we would do 5 squared plus 4 squared equals C squared. And you'd have 25 plus 16. You have 41 square root both sides, and you get 6.4 would be the magnitude. So your component form represents A and B in Pythagorean theorem. You could actually have that down there. Your component form represents your A number and your B number when you do your right triangle. So anytime they give you a component form, that's A and B in your right triangle, you can just do A squared plus B squared equals C squared, and you can get your magnitude. Okay, moving on. We good there? Moving to the next one. Okay, find the magnitude of vector AB. Okay, if it's got a component form of negative 4, 3. Okay, we just did one like that, so what do we do? Okay, this right here represents A and B in your Pythagorean theorem. So we would just plug it into, we would have negative 4 squared plus 3 squared equals C squared. The component form gives you your A and your B for your right triangle. And you're going to get 16 plus 9. You're going to get 25 equals C squared. Square root both sides. C has to be 5. So your magnitude for that vector would be a 5. If a vector is telling you to go 4 left and 3 up, then that's going to have a vector that's length is 5. It's going to be a 3, 4, 5 right triangle. 3, 4, 5 right triangle. Okay, a resultant vector is the result of adding two or combining two vectors together. You combine two vectors together, you're going to get one big vector. So notice how the first thing it did was went from A to B, and then the second thing it did was went from B to C. If you put those two vectors together, you would just have one big vector from A to C. So let's put these points in here. This point is 0, 0. And this point is over 1, 2, 3, 4, 5, 6, 7, 8, 9, and up 1. This is the point 9, 1. So this vector right here from A to B, so vector AB is actually a 9, 1 vector. It's 9 to the right and 1 up. So that vector is a 9, 1 vector. Vector BC, you would go 7, 1, 2, 3, 4, 5, 6, 7 over to the right, and you go 1, 2, 3, 4, 5, 6, 7 down. So it would be 7 to the right and 7 down. 7, negative 7. The resultant vector AC would be the result of combining those two vectors together. If you combined a 9 to the right and a 7 to the right, what would you get there? You get a 16 to the right. If you combined a 1 up with a 7 down, you get 6 down. That vector is over 16 and down 6. And that's actually that coordinate right there. When you start at the origin, your resultant vector is going to be the same as that point if you start at the origin. So this is actually the point 16, negative 6. So you did go over 16 and down 6 to get to that vector. So combining those two vectors together gives you your resultant vector. Add the two vectors together. So basically you could put a plus sign in there and just combine them. Combine the two vectors. Last one. That was not this one. Okay, Lisa and Greg are moving a tool cabinet on rollers. One's pushing one way and one's pushing a different way. And it says the forces they apply to the cabinet are represented by these two vectors. So negative 2, negative 5, that means 2 left and 5 down. And this vector is 1 right and 4 down. So they want us to find the resultant vector. So the resultant vector would be vector R. We want to add vector P and vector Q together. So we're going to add or combine the components of the vectors. We're going to add the components or combine the components of the vectors. So we've got vector P is negative 2, negative 5. We've got vector Q is 1, negative 4. And we want to combine those two, so I can put a plus sign there. Vector R is what would we get when we combine those two. Combine a negative 2 with a positive 1, you get negative 1. And you combine a negative 5 and a negative 4, you get negative 9. So your vector, your resultant vector would be a negative 1, negative 9 vector. The result of adding the two vectors together. All right, we need to look at the answers to our homework next.